if for a square matrix A square minus 3A plus I equal to 0 and A inverse equal to xA plus yi, then the value of x plus y is dash. This type of question will come for xA+yI mains in integer type question. So let us see how to solve this. So it is given that A square minus 3A plus I equal to 0. 0 is the 0 matrix. Let us take this equation as number 1. Now let us bring this minus 3A to the right side. So the equation becomes A square plus I, just I, equal to 3A. Now we have to pre-multiply or post-multiply by A inverse, because here matrix multiplication is not commutative. That means A dot A into B not equal to B into A in case of matrix A and B. So let us pre-multiply the above equation by A inverse. So what happens? A inverse into A square plus I equal to 3 into A inverse A. Okay. So since matrix multiplication is distributive, we can take A inverse inside the bracket. So this will become A inverse into A square plus A inverse into I. So here what happens? A inverse into A, that is I, identity matrix I. So now we are going to split this A square into A into A. A square A inverse into A inverse into A into A. A square will become A into A plus A inverse I is A inverse, just A inverse, which is equal to 3 into I. So again we can put bracket for A inverse into A, because matrix multiplication is associative. It is not commutative, but it is associative. So this becomes A inverse into A in plus A inverse equal to 3I. Again this A inverse into A becomes I into A plus A inverse equal to 3I. Now let us substitute the given value A inverse as xA+yI from the question. So substituting A inverse equal to xA+yI in the above equation, this becomes, above equation becomes simply A plus A, in place of A inverse we are going to substitute xA+yI. xA+yI equal to 3 into I. Okay, from the first two terms, let us take A commonly outside. So this is matrix. So the element here is 1 plus I, 1 plus x plus y into I. This x and y are elements, means just a numbers, but A and I are matrices. So now let us equate this each and every row or column to the corresponding row and column of the RHS, LHS to the RHS. Since it has y into I means identity matrix. So for example, let me take only one element from this equation, that is A 1, 2. That means first row and second column of the matrix. That element alone we are taking. So this will become 1 plus x into some some element of A. Okay, element of A, let us take it as, here we will take it as B. This one will become A12 plus y into I. What is the element in first row second column of I? That is 0 plus 0 equal to, again here also it is 0 because identity matrix first row second column is 0. The element of first row and second column is 0. Let us equate that. So if you equate this, what happens? We will get 1 plus x into some element 1 to a12 equal to 0. This implies 1 plus x equal to 0. So x we will get it as minus 1. Now let us substitute this x equal to minus 1 in this equation. Let us take this equation as 2. Second equation. So substituting x equal to minus 1 in second equation, we get first term becomes 0, y into I equal to 3i. So corresponding elements, if we equate directly, we will get y as 3. So what do we get? X as 1, x as minus 1 and y as 3. Therefore, x plus y is equal to minus 1 plus 3 equal to 2. This is the answer.